What is up, Flutter devs? Today we're going to build this thing that you see on the screen, which apparently is called a face pile because it's a pile of faces. A little story to go with today's Widget Workshop. A friend of mine reached out and said that he had to build one of these for the app that he works on for the company where he works these days. But of course, that company is too cool to use Flutter, so he had to build this with Android. And he only had to build what you're seeing here on the screen, just show some faces slightly overlapping. And of course, because the Android APIs are just terrible, that was a real pain to accomplish even in this static form. He started with traditional Android view hierarchies. Then he said, maybe this would be easier with Jetpack Compose. So he goes over there. An hour later, he says, I've looked through all the documentation, and I don't think Jetpack Compose knows how to display an image from the network.
You serious?
So if you want to display an image from the network with Jetpack Compose, apparently you have to bring in a third-party package. And after he went down that road for a little bit, he said, all right, forget it. I'm going back to the traditional view hierarchy. He managed to figure it out with traditional views. And then after he got this static version of a face pile working, his product team said, oh, just kidding. We don't need that. Welcome to the world of technology and app development. But what we're going to build today isn't just this static display that you see before you. In reality, you're always going to want to be able to add and remove faces from something like this, and you're going to want to have a nice animated interaction when you do it. So we can see here that we can add new faces to this, and we can remove faces from it. We can go all the way down to nothing, in fact, and then we can bring them back. And notice that up to a certain size, we have the same spacing between them, but then we hit a maximum width. And from there, we start packing them in closer and closer because we don't want to exceed that width. So we're going to figure all of that out today. The first time around, it probably took me a couple hours to create this. Hopefully today, we're going to do this in less than an hour. So let's jump into it. Here we are with an empty project, or empty enough. We have a blank area to work with, a blank canvas, and we're going to figure out how to create this animated dynamic face pile thing. Now, we could probably start this from a number of different places. I generally like to start from the simplest piece of the puzzle and then work my way up. I like to build small to large, compose things together. And so at the smallest level, we know that we're going to display faces. And each of those faces probably is associated with a user. And we're going to need, obviously, a photo URL. But because we're loading images from the network, or really, frankly, regardless of where you load images from, it can take time to load the image. And therefore, we want to display something while the image is loading. For that purpose, we're also going to use the first name of each user. So we're going to display the name in text and then fade the image in when it loads. And because we're going to use the same kind of face widget over and over again, and we want those faces to kind of continue existing as we rebuild our widget tree, we know that we're going to need a unique ID per face widget. And that's going to lead us to model this concept of what we'll call a user. Now, you could call it a face, I guess. You can call it whatever you want. It's essentially a view model, but let's start by modeling that and then build out. So we'll create a class called user. Let me see, I'll scroll down to get you a little more space here. And I said we're going to want an ID. We're going to want a first name. And we're going to want an avatar URL. All right, now let's generate the constructor for this. And I always prefer named parameters in my constructors. By the way, if you have any idea how I can tell Android Studio to automatically use a named constructor, let me know in the comments. Now, I don't know if we're going to need this next part, but just in case, let's generate the equals and hash code, and that's going to be based on the ID. And this way, if we have, let's say, a set of users, we can prevent duplicates by correctly honoring the hash code and equality operator. So this user, we're going to have one of these data structures per face that you see on the screen. This is totally non-visual. This is logical. This is the data structure. We now need a widget that knows how to take one of these user objects and show the name and then load the image. So let's go create that. And we'll call that, for lack of a better name, we'll call that avatar circle. It'll be a stateful widget. Avatar circle. All right. And I said that it's going to work with one of these users, so we need to take in a user. We also need to know how large to make it. You could hard code this if you want. I prefer typically to do to make things like sizes and colors parameterizable, and then sometimes offer a default value. So we'll take in face size. It's just one dimension because a circle is a square. So the width and the height are equal. We'll call them both face size. Or I guess really, because this is, let's just call it size. Let's call it size. This is an avatar circle, not a face circle, and size applies to the whole widget, so we'll just call it size. But we also want a color for the name label, and we want a color for the background. And with those, let's generate a constructor. And this time it's a named constructor automatically because Flutter is smart enough to do that for widgets, but doesn't do that for Dart objects in general. Actually, the user is required. The size, let's default to 48. It can be any default you want. I think 48 is a reasonable default. We will require the colors. We're not going to make any assumptions there. Now, what do we actually want to display in this avatar circle? Well, obviously we need it to be a circle, which means at some level we need to crop with a circle. We know that circle needs to have a width and a height equal to the given size. But we also want a drop shadow, because when you're overlapping things, it's helpful to have a little bit of depth there so you can see what is on top of what really clearly. And we know that a container widget gives us width, gives us height, gives us a circle shape, gives us a drop shadow, and gives us clipping. So we'll take this container here, and its width will be widget.size. Its height will be widget.size. We will say clip behavior is clip.anti-alias. Anything other than clip.none will give you clipping. And then we want a decoration. Box decoration shape is going to be box shape.circle. That's going to give us a circle clip behavior. We want the background color to be widget.background color. And then that will, well, let's go ahead and see what that looks like, and then we'll build from there. Let's come up here to this scaffold that I already have sitting here, and let's give it a body where we will center an avatar circle. And it's going to want a user. For now, we will hard code this in here. So ID is fake. First name will be me. Avatar URL for now doesn't matter. Then we want a name label color, which will go with white. And then the background color, let me see what I used the last time that I worked on this. Actually, so last time I did this, I didn't use white up here. I used a light gray. So that wouldn't, I'm sorry. This was, no. I had it inverted. I used a very dark gray last time, and the background was actually a lighter gray. And it's going to complain about me not making things const. Oh, that warning is really annoying. I guess it's good. You should make everything const that you can, but while you're developing, it's so annoying to have these stupid squigglies appear everywhere. Because eventually this is not going to be const, and so it's just a distraction. Anyway, so we have the fake user here. We have the name label color, background color, and that's centered in a scaffold. Let's save that. And does it realize? Let's see. Do you know that you're running? Lost connection to device. Awesome. Okay, here's what we got so far. We have the circle of the appropriate size. We're missing a drop shadow. We're missing text. We're missing an image. Let's go add those details. So in here for the drop shadow, we will use a box shadow. Box shadow colors black with opacity, I don't know, 0.2 maybe. Blur, let's go 5. Offset, let's go maybe 3 pixels on the y-axis. And then for the child of the container, we're going to center a text widget, which is going to be widget.user.firstname. And we're going to say max lines 1. Now, there isn't going to be much room here, so a lot of names are going to overflow, but you can adjust that behavior as you see fit. We're going to take the easy approach of limiting to 1 line, and then we're going to say text overflow ellipsis, so that will say ... if it's too long. Then the text style, say widget name label color, we'll go with a font size of 8, make it very small, and the font weight, we're going to make it bold. Widget.user.name label color. Let's see, what did I not call it? Oh no, so it was sorry, widget dot. What am I, oh, can't be const, I guess, in that case. Sorry. All right, save that. Now we've got the name. And we have the drop shadow. Okay, now we still need the image. What do we do for the image? Well, first, let's come over here to randomuser.me. This is a tool where you can get a whole bunch of random user data. Names, photos, probably addresses if you want them. I don't know. It's just a bunch of stuff you might need. So let's see here. We have ladies, we have gentlemen, apparently Lego people as well. This looks pretty much like me, right? Let's copy the image address and we'll come back in here and we're going to hard code that image address into our hard coded user. And then what we're going to do is, and right now it's not going to do anything because we're not displaying an image, but down here in our avatar circle widget, we're going to come inside the container. Remember, the container is cropped, so it's cutting a circle out. So inside the container, we're going to create a stack. We're going to leave the text in the stack, but then on top of the text, we are going to display an image. And specifically, we're going to use a fade in image. And we're going to say memory network. Now this placeholder thing, we're going to say K transparent image. I had to import a package to get the transparent image. Let's see. In fact, what is it complaining about here? Yeah. So this package right here, I needed to add this to my pub spec. I don't know why Flutter includes the fade in image widget and then still years later defers to this third-party package. I don't know the rationale there. A lot of people want the ability to start invisible and then fade in an image. I don't see why we have to import or we have to load an external third-party package just to get that, but it is what it is. Now for the image, we're going to say widget user avatar URL and then fade in duration. We're going to go with 250 milliseconds. Save that. Oh, and let's see. I'm missing static. Maybe a hot restart will solve that. Let's see. Sure does. And there we go. We get the little fade in right there. So now we've got a face circle of the appropriate size clipped to the shape with a drop shadow. That's the basic building block of the face pile. Now, in theory, if we can figure out how to lay out multiple of those, either with, that's two situations, when we don't need all the available space and when we exceed the available space. Those are two different layout concerns. And then we need the ability to add more faces with animation and remove faces. I guess let's try and handle the layout first, and then we'll come back and we'll make them appear and disappear. So let's start by declaring a face pile widget. And this will be a stateful widget. Call it face pile. Now a face pile, of course, displays a list of users. So we're going to have a list of user called the users. Also, we're going to, again, make the face size configurable, though it will have a default value. And then there's going to be the face % overlap. In other words, if that value is 0.1, that means 10% overlap. One face sits 10% over another. Let's take those into a constructor. Actually, again, face size, we will default to 48. But the rest is required. So now let's get rid of this hard-coded thing. Cut that out of there. And now let me see, I want to constrain the size here for our demo purposes. So let me see what I did last time for this. So keep the scaffold, keep the center, then we're going to have a constrained box with constraints of a max width of 200 pixels, and then we're going to use our face pile widget right here. And then within that widget, we need to pass users. And I made a face % overlap required. Instead, we're going to introduce a default value. We're going to do 10% overlap by default. Okay, let's bring back that hard-coded user right here. I cut the whole widget, but let me just bring back the user part. What we're going to do in a few minutes is we're actually going to load a group of users from this website in our code so that we have random users to deal with. But for now, let's try to get some of this set up with just a single hard-coded user, or maybe 2 or 3. We don't need to parameterize this until we're ready to actually see that stuff in action. So down here in face pile, what do we want to do? I guess the first question is, fundamentally, what layout makes sense if we're going to display these circles and overlap them a little bit? You might be tempted to use a row, but a row is not going to work because a row very much expects for each item to not overlap the other. And if anything, if you manage to make that work, you're going to be hacking it all to death. And really what's more appropriate here is a stack. A stack allows you to use any XY position within the stack to display children as long as you use a positioned widget. So let's see if we can start building this thing out. First, I want the height of this thing to be equal to the height of a single face. That's one constraint out of the way. And then I said we want a stack. Okay, well, here's a stack. And we're going to get rid of the clip behavior because at a minimum, the shadow from one of these faces will sit outside of the stack itself, and we don't want to give it a hard cutoff there. So we're going to say clip.none for the clip behavior. And then the stack has children. And this is where we want to place all of our faces. I guess to start off, let's just take the one face that we've got and let's put it at the top left to make sure that we're showing something. We'll use a positioned widget. We will say left 0, top 0, height, widget dot face size. And I think we also have a width too. So widget dot face size. And what is this complaining about? Okay, it doesn't have child. That's fine. The child is going to be an avatar circle, which wants a user. We'll say widget users first, because right now we know there's exactly one that we're passing in. And then I forget, let's see if I can remember what these two colors were. I think we said that the name label color was 222222, and then the background color was 8s. Let's save that. Okay, and there it is. Notice it's off center. Why is it off center? Because the face pile is 200 pixels wide, and so we should be the left side should be 100 pixels to the left of center. That's why it's off center. So this is a good indication that actually this is where we expect it to be. Now let's bring in multiple faces and see if we can start to figure out how to calculate these positions. Obviously, if I save that, we still just have this one face because we're explicitly accessing the first item in the list of users, but now we need to do something for all of the users. How do we want to lay this out? I guess what we want to do is we want to start from the left, and then from there we just kind of want to put one after the other after the other. And because a stack automatically supports a z-index, the later faces will automatically overlap the earlier faces. So the left parameter is really what this comes down to. And we want many positioned things, right? So we want to say for variable I is equal to 0, where I is less than widget dot users dot length I plus equals 1. I'm using I as a variable instead of iterating directly because we're going to need to use the I value in the calculation. We're going to need to use the index in the calculation. So here we can say, for example, I times widget dot face percent overlap. And actually, that's not quite right. It's 1 minus that. Because if we're overlapping by 10%, it means that we want to display 90% of a face, right? To overlap 10%, it means you're showing 90%. And that's the number that we want right here. We want I, the index, times the percentage of each face that we're displaying. But we also need to multiply that by the size of a face. So this will begin at 0, and then it will position one face further and further left, and they will share 90%. They will display 90% of each face, and they will overlap 10%, which is this overlap value. Let's save that and see what happens. All right, there it is. Now, one interesting thing is that it doesn't seem like the drop shadow is really showing through. Maybe it's just too light, but I don't like how they're kind of blending into each other. Let's see what happens if we give the drop shadow a little bit darker of an opacity. Yeah, it's still, I guess you can kind of see it. It's just, it's so much darker against the white or the white background than it is on the other image. We'll see how it goes. I don't think I've screwed anything up, but we'll see if something comes up later. Now, one problem we do have here, it's not so visible with 4 users. Let's go back to 3 users. And let's add around this, for now at least, a decorated box. Decorated box with a decoration, box decoration. I want a border. Border dot all, color is gray. Notice that we're filling from the left to the right. And that's really not how this should work. It should be centered. If we don't need all the available space, these faces should be centered. And here begins our foray into a bit of a more complicated approach to this situation. We need to know how much space is available. Without knowing our overall bounds, we can't make necessary decisions for how to lay out these faces. This is the situation where one needs to use something like a layout builder. So above this sized box, I'll say stream builder to generate it, but then we're going to change it to a layout builder. Layout builder, get rid of that, and this is constraints. So now we have access to, for example, constraints.maxWidth. And we have to make a decision at this point. Either we need all the available space or we don't. So we need to calculate that. We need to actually figure that out. One thing is that this number right here, I think we're going to need up above. So I'm going to cut this out and I'm going to call this face percent visible, which is the inverse of face percent overlap. And then I want to calculate I want the intrinsic width. So imagine that we are unbounded. Imagine there are no bounds. How wide would we choose to be? Let's calculate that. We'll call that intrinsic width. Now, if face count is 1, then our intrinsic width, if it's 1, then our intrinsic width is the size of one face. If it's 0, our intrinsic width is 0, but it really doesn't matter in that case anyway. So what we're going to say is widget.users is greater than 1, because we're going to do some math here that requires a length greater than 1. We're going to say 1 plus face percent visible times widget.use. I'm tired of typing this out here. Let's say faces count, that's going to equal widget users.length. So faces count, we're going to subtract 1. So here's the math that we are calculating. If you imagine a number of faces laid out. If there was 0 overlap, the width would be the number of faces times the width per face. But the moment that you start overlapping, the calculation becomes 1 full-size face and then n minus 1 90% of faces. You're always going to have one fully visible face, but then all the other ones are at least partially overlapped. That's what we're calculating here. That's what this 1 plus right here, this represents the fully visible face. And then here, n minus 1 faces times 90% visible. And then we're going to multiply by face size. Now, if there's only one face or less, we'll just go ahead and make it the size of one face. So again, if there was no overlap, it would just be this face size times the number of faces. But because we're overlapping, we have one full-size face, and then we have n minus 1 partially visible faces. And that gives us the natural width. If we're not bounded at all, that's our natural width. Now, given the incoming constraints and given the intrinsic width, we now need to decide what is our left offset. And when I mean the left offset, I mean, like, we're going to say left offset plus this other stuff. Before, our left offset was 0, which is why we were always pushed to the left side. But now we're going to calculate a left offset based on the incoming constraints and our intrinsic width. So we're going to say if intrinsic width is greater than constraints.max width, this means we want to be wider than we are. We don't have enough room for our natural width. So in this case, our left offset is going to be 0. We're going to go all the way from the left to the right, all the way from the left to the right. But if that's not the case, then our left offset we need to calculate. And that's going to be constraints.max width minus intrinsic width divided by 2. This is essentially an average. So this will horizontally center our content. Once our content is laid out at its intrinsic width, we will be horizontally centered. Okay, let's save that. And look at that. We are horizontally centered. But we still have a problem. Let's add a few more users. Look at this. Now we're too big. We're too big to fit. And so we do start at the left, but look, we blow right past the right side of our available width. We just keep doing the same overlap and we go right past our bounds. That's no good. And this is the second part of the layout concern. We dealt with the part where we take up less space than available. Now what do we do when we are taking up more space than available? Well, what this means is, you see this face percent visible parameter right here, or variable? It's not actually constant. We don't actually know what it is. We know what we want it to be, and that's what we set it to up here. But if we don't have enough room, we need to shrink that number down. We need to do it right here. We need to shrink it right here. So we'll say face percent visible equals constraints.max width divided by widget.face size minus 1 divided by faces count minus 1. If we take up too much space, then that equation right there will determine how much overlap we require so that we fit in the available space. Now this minus 1 here, remember I told you there's one face that's always fully visible. That's why we have these minus 1s. And now look at that. Now we're taking it, now we are exactly constrained to the amount of space that we have. And I'm thinking, in terms of what we do next, let's take inventory about what remains. We don't yet have the ability to add and remove faces at all. And that also prevents us from being absolutely sure that this layout works when we grow and shrink in number. Once we have the ability to add and remove users, we still don't have entrance animations and we don't have exit animations. So in terms of solving those problems, I think first, let's add buttons to add and remove users. And we'll just stick with hard-coded users for now. We'll build this whole thing out with hard-coded users, I guess. The same user over and over again. And then once everything's working, we'll actually use random user through a package, and we will fill these in with truly random users. So first, I'm gonna, in the floating action button area here, I'm going to add a couple buttons. So here we have this scaffold, and everything is in the body of the scaffold right now. I'm gonna come down here, and we're gonna put something in the floating action button property. And let me look up in my notes what I did here previously. Okay, so we're just gonna do a row, and we're gonna make sure that we don't expand. We just wanna be the minimum size possible. And then we're going to have two floating action buttons, one to add, one to subtract. So floating action button, child const icon icons dot remove on pressed, we will say remove user from pile. And we're going to make it mini because these things are way too large by default on desktop. Okay, and then we're going to copy that, and then we're going to change this method to say add user to pile. And we're going to say icons.add. And then between these two, we're going to have a sized box, add a little bit of space between them, a sized box with width of 24. And then up here above our build method, we're going to create a method called add user to pile, remove user from pile. Now this requires that we have a pile to add and remove them, right? So we will have a final face pile users list right there. And then we will say, let me go grab that hard-coded user definition. We will say set state, face pile users, add, there we go. We'll make that a const. And then we will say if face pile users is not empty, then face pile users, I guess we'll say remove last. Although, let's see. I want that to be random. I don't want to just always remove the last one. So let's say random index, random next int, face pile users dot length. Import that. Oh, sorry, not file pile, face pile. Okay, and then we're going to say face pile users remove at random index. Okay. And then down here, instead of having all of these users in here, we're going to get rid of this hard-coded list and just show the face pile users. Looks like I deleted too much. We need face pile here. There we go. Save that. And we'll probably need a hot restart because we added something to our state object. Okay, we have these two buttons. Let's add. Okay, that's proving that our layout is working as we grow. And now it's working as we shrink. All right, so we're making progress. Next, let's animate not the appearance or disappearance, but as we add things in here, as the existing avatars or faces change their position, let's animate that change. And thanks to implicitly animated widgets, when we come down here to positioned, we're going to get this capability practically for free. We're going to go, instead of positioned, we're going to use animated positioned. And then we need to provide a duration for how long each one of these animations should last. And we're going to go with 250 milliseconds. And we're also going to specify an ease in-out curve so that the motion doesn't look too choppy. Let's save that. How about that? Just like that, we're getting animation for free. That's weird. They that random. I remember now. So I was gonna say the random index is not working because we're always removing the last one. Remember I mentioned at the very beginning of this that we need a key. Or we need an ID per user because we need the widgets to remember which is which over time. So we will have a value key whose value is widget users I.id. And now for that, we still have an issue because I'm giving them all the same ID because they're all hard coded. Instead, we will create a string that says random next int, I don't know, 10,000. That's not the final solution to that problem, but it should solve our problem for right now. And it's duplicate keys because they're null for the existing ones. Let's do a hot restart. Okay, so now we can add them like before, and now you see they're disappearing from random places. And the reason that we're making it random is because in a real group, you don't know when people are coming and going. So we make it random to make sure it's going to work for our use case. Okay. Now we need the ability to animate appearance and disappearance. And there are a number of ways that you could try to accomplish this. And there's also a number of different animations that you could do. Like we're going to have it kind of pop in and we're going to have it shrink out. But instead of shrinking out, you could decide to make it like fly up and then disappear and fade out. But by having the animation, by animating in and out without changing the position, that's going to allow us to centralize that animation in a new widget specifically designed to do that animation, to make the appearance and disappearance work. So we're going to make our lives a little bit easier by not flying up and fading out. So we'll create a stateful widget called appearing and disappearing face. And what are we going to need here? We're going to bring in the user. We're going to take in a face size. We're going to have the ability to show and hide the face. And then we're going to take a callback so that we know when we're done disappearing. Because when we don't want to remove a face until it's done animating out. And so we need to know when it's done animating out. All right, user is required. Face size will default to 48. Show face is required. On disappear is required. Now I said we're going to kind of pop in and pop out. Both of those are scaling transforms. Therefore, we're going to need an animation controller. We'll call it scale controller. And we're also going to create an animation so that we can apply elastic or elasticity curves to that animation, to the controller, I should say. And so we're going to create this animation. Now to coordinate the animation, we're going to need a single ticker provider state mixin thing. And then we're going to need in init state to actually instantiate these things. Scale controller equals animation controller. The vsync is this. And the duration, we're going to say const duration milliseconds 500. We're also going to add a status listener because I told you that we need to invoke that callback when we're done disappearing. So we're going to animate forward. Then that's when the face appears. And then when the face disappears, we're going to animate backward. So we're going to say if status equals animation status dot dismissed, which actually means it is done reversing. Then we're going to say widget on disappear so that the widget can do whatever it needs to do. Now that's the controller. We also need the animation with the curves. So we're going to have a curved animation. The parent is going to be the scale controller, and the curve is going to be curves dot elastic out. And if we init those things, then we must dispose of those things. So here we will say scale controller dot dispose. Now we also have another situation we need to deal with, which is that at some point this widget is going to be told to, well, show or hide a face. Technically, this widget could start by not showing a face, then show it, and then hide it. The point is we need to be able to take action whenever that request changes. In other words, whenever show face goes from false to true or true to false, we need to do the appropriate thing. We're going to create a method to handle that situation, and then we're going to invoke it from multiple places. We're going to call it sync scale animation with widget. And there are 2 times that we need to do this. First, when we init state, we need to make sure that if we want to show the face, we show the face. But also we need to override did update widget, and we need to call it from there as well. Meaning whenever the widget changes, we need to look at that value and take the appropriate action. Now, what do we want to do in this sync method? If we want to show the face and we are not already showing the face and we are not already animating forward, then we actually have something to do. And this should be scale controller dot status. So if we want to show the face, if we are not yet showing the face, and if we are not in the process of showing the face, then we want to say scale controller animate forward, which means show the face. Otherwise, if we don't want to show the face and the face is not currently hidden and we are not currently in the process of hiding the face, then we want to hide the face. Okay. Now, what do we do with that information? We have an animation. We make it go forward and backward at the appropriate time. How do we use that visually? Well, first, we're always going to take up the amount of space needed for a face. Regardless of what size we are, we're going to take up the standard size, and then we're going to center the smaller face inside of ourselves. So within that sized box, we're going to have a center widget. We're going to have an animated builder, which is an animated builder is a widget that rebuilds itself whenever an animation changes. So we're going to pass in the scale animation. And then there's the builder part, which takes in a context and a child. The child doesn't matter in this case. Actually, I guess, well, we could use the child here. Let me show you both approaches. So ignoring the child argument, we could say transform.scale. This is what actually applies the visual scaling. How much do we want to scale? We want to scale with whatever the scale animation says it should be. 0%, 50%, 100%, it's up to that animation. And then what are we scaling? We are scaling an avatar circle with this user and this standard face size, and then here are the colors again. And by the way, you could generalize this for any widget. If you were to take in the child, if we were to actually take avatar circle into our widget as a child, we could generalize all this for any widget. I just didn't happen to do that because scalability has nothing to do with this exercise. Now, I mentioned before about this child argument. For those of you that don't know, the reason for this child argument is that sometimes you have a subtree like this where part of the tree actually does need to change with the animation, but part of the subtree doesn't need to change, like this avatar circle. This avatar circle, it does care about the widget user and face size, but it doesn't care about the scale animation. So we can do this. We can cut that out and we can pass it as a child to the animated builder itself. And what's the benefit of this? even though our builder runs 60 times per second, and even though the transform scale widget is rebuilt 60 times per second, this avatar circle right here is only built one time. Given this user and this face size, we only instantiate this widget one time, and this same widget keeps getting passed into our builder. So this is a performance concern. It's not functional. You don't ever need to use this child property. But if you have things that don't care about the current state of the animation, you can build them once in this child property, and then it gets passed into your builder to be used inside of your visual animation. Either way is fine in this case, not a big deal. Okay, so this should give us the visual behavior that we want. But we still have a problem here, and let's see how this looks. We may not see any animation at all. Let's see. So if we remove stuff, there's no animation. And when we add, actually, I'm sorry, I'm not even using this widget yet, am I? We're still going to have a problem, but let me at least use this widget. So here's the widget that we just created. And let's see. Okay, I declared this higher up than I wanted to. I want to declare this below the face pile so that it's easier to read from high level concept to lower level concept. Now coming into the face pile, here's our avatar circle. Instead of an avatar circle, let's do appearing and disappearing face. And then show face. For now, it's always going to be true because we don't know when that should be false yet. We need on disappear. We'll say to do. And then face size will be widget.face size. Let's save that. Let's do a hot restart. Okay, so we do have the appearance animation, but watch what happens when we remove them. No disappearance animation. Why is that? The reason is that we are literally removing the user data the second we press this minus button. The moment we press the minus button, we forget that user ever existed, because up here in this users list, we remove it and then it's gone. As far as this widget is concerned, it's not there, because once we remove that user from this list, well, we come down here, we rerun our build method, and look, we're only building the users in that list. And what this means is that we actually need to retain a second list of users. There's a difference between the users that are currently in the group and the users that we are currently displaying. That's the problem we have to solve. So to solve that, in this face pile state object, we're going to declare visible users. And this list is not necessarily the same as this list. Okay, the visible users is going to be based on the users that we're given, but when we remove a user, we're going to hold on to it in here for a little while longer. Now, because we're introducing this list, we have to add some behavior to synchronize our lists. So in init state, we're going to say visible users, add all widget.users. That'll get us started. And then I think in did update widget, we're going to need to do something here as well. I guess in here again, in both cases, we're going to have to synchronize. Now, the init state synchronization is very simple because we know that we're starting empty, and so we can just add all of these users. But when we get down here to did update widget, we may have to add and remove certain user. Well, that's not true either. But we don't want to add any users that we've already added. That's the point. So instead of doing two different implementations, let me say void sync users with pile. And let's call that from both of these places, sync users with pile. And then the question is, what do we want to do here? we want to figure out the new users, the users that don't already exist in our list. So we're going to say widget.users. And when I say don't exist in our list, these are the users that are not yet visible. They were just added to the list. We need to figure out which users those are. We want to select from the users that we are given. And which users do we want? Well, looking at every user that we're given, we're then going to look through visible users, and we're going to find any situation. Let's see. This is probably not at all an efficient way to do this. We're essentially running a diff, but we'll say visible user equals to user is empty. This should be an arrow. Okay, so we're looping through every user that we're given, and then we're saying, okay, for every single user that we are given, look at every user that is currently visible. And if there is no visible user that is the same as the user that we are given, then this must be a new user. Now, you may have a much more concise and efficient way to implement this. This was just off the cuff, the way that I would do it, because I use these where methods a lot. Obviously, it's not efficient to loop through the second list for every item in the first list, but I'm just not concerned about that efficiency right now. The point is, this will give us any users that are new, that we haven't seen before, that are not visible. And then with each of those, we want to say visible users, add all new users. Okay? And now we're synchronized. In the case of init state, the new users is going to be all the users. But when we run did update widget, the difference is probably going to be 1 or 2 users at a time. Now, notice I am not saying set state here. And that's because both of these things are run in methods that will then rebuild. You can't call set state in init state or did update widget. And that might be a problem in a minute, but let's see. I don't know yet if that's going to be a problem. Okay, so now visible users is our state of truth. So we want to take visible users. We don't want widget.users. We want visible users. And let's see any other place that we're using widget.users. We don't want that there. We don't want that there. Oh, and I was passing in the wrong user the entire time right here, or at least in the latest change. This should be visible users I. Okay. And then let me make sure that this reference is not being used in places where it shouldn't be. That's correct. Okay. So now this widget, the source of truth, is this list right here. From a visual perspective, we don't care what you give us in the widget. We only care what's in the visible users list. Now, I think we're still going to have, let me do a hot restart because we added a state variable. I think we're still going to have the same problem because we haven't, actually, I think now they're never going to disappear. Okay, so I just clicked minus a bunch of times and they never disappeared. And why didn't they disappear? One thing is that we are never passing in false here. Show face is not always true. We want to say it's only true if widget.users contains visible users I. Right? So we only want to show the face if this user is one of the users that was given to our widget. Now, this will make it disappear, but I think we're still going to have layout problems. Again, let me do a hot restart to get us back to a good known state. And I'll say add. Okay, now remove. They removed, but notice that our layout is wrong. Why is our layout wrong? Our layout is wrong because even though the animation is running, we never implemented on disappear. So we're still showing the widgets. They're just invisible because they disappeared. We need in on disappear, we need to remove those widgets. So I think this will work if we say set state visible users. There could be a race condition here, I'm not sure, but I think we can say remove, and we'll say, so the problem is, so we can say visible users I. The problem is, when exactly does this line resolve itself? Because imagine that we remove 2 users or 3 users really quickly. Is this number going to be wrong? Is it possible that we remove the wrong user or we access an index out of bounds? This is a language question. I don't know when exactly this expression evaluates. But let's try it. Let's save that. Not terminal, I want run. Let's do a hot restart. Okay, seems to work. So that's the functionality. We built a face. So we started with the circle, gave it a background color, gave it a drop shadow, put a name text on the center of the circle, then added a fade in image from the network, which we cropped to a circle. Then we figured out how to lay them out horizontally in a stack. First, we dealt with the case where we don't need the available space. Then we dealt with the case where we naturally want to exceed the available space. Then we animated changes between the two. Then we animated appearance. Then we animated disappearance. And that gives us the final product. But for those of you interested in something that actually looks convincing, we want random users, right? So first let me go remove this border because we don't need that anymore. And I'm going to show you how we're going to get random users. So we'll get rid of this decorated box. Now I've included in my pub spec here a package that implements API support for random user. Unfortunately, this package is out of date. It doesn't have null safety. So by the way, I've been building this entire time without null safety. So if one of you, if you know the person who's working on it, maybe get them to go update it, or maybe you create an alternative version of this package. But let's see what we can do to bring in random users. Now, the approach that I'm going to take to this is that at the very beginning of the app, essentially, I'm going to load 20 random users, and that's it. I'm not going to load any more than that. We're just going to keep selecting from the group of available users. So up here in the demo state object, we will declare a list of user called available users. And then we're going to implement init state, super.init state, and in a moment we're going to implement a method called populate fake users. Now the point of populate fake users is to actually communicate with this web service and get us the data that we want. Populate fake users. We're going to say random users client equals random user. This is something that came from that package. We're now using the random user package. And then we're going to say random users equals await random user client.get users. And we're going to ask for 20 results. Then we're going to convert those random users from the web service into our definition of users. So we're going to say random users dot map. And then we're going to construct our own user object. Now these users technically have something called an ID. Unfortunately, a lot of times the ID is null, and that's no good for us. So we're going to use something else for the ID, which is the picture. We're pretty sure they all have thumbnails, and the thumbnails should be different for every user, so that should work as an ID. And then random user.name.first for the first name, And then for the avatar URL, we're going to use that same value as we did for the picture. And then we're going to convert this to a list. Okay, so now we have 20 users sitting in this list. Now this list is different from our FacePile users. This is the pool of all the users we can select from, and then we have the ones that we're actually showing, which means we now need to adjust our behavior for adding and removing these things. If we have no more available users, if available users is empty, we're not going to add any more. You can never add more than 20. That's the restriction that we're putting on here. But now, instead of this thing right here, we're just going to take the last item off the users list. We're going to say add available users dot remove last. Okay, and we set state already, so that's good. And now remove user from pile. This is similar, except we need to grab the removed user and we need to add it back to the available users. And we'll actually add that to the front so that we don't immediately get the same user we just removed. Oh, sorry, it should be insert. Because remember, we had to load these from the network, so we only have a certain pool. If we remove them and throw them away, then quickly we're going to run out of available users. So again, what we're doing is we're filling in available users, and then we're moving users from this list to this list, and then from this list back to this list. Okay, let's save that. Let's do a hot restart. And there we go. Can add a whole bunch in there, and then we can remove them. And that, folks, is an animated face pile in Flutter. I'm not sure exactly how long we took. I wasn't paying attention, but definitely less than the many hours that my friend spent trying to get it implemented on Android, only to have his company tell him that, no, we're not really going to use it. So this is why I love Flutter. You can do a lot more quickly. You can do a lot more with a lot less. Hopefully you learned something here today. I've decided to try to make my Widget Workshop source code public from here on out. So if you go over to my GitHub, if you go to my Widget Workshops, plural, repository, you should be able to find this in there, and I'm going to add more Widget Workshops to there moving forward. So add any questions or comments that you may have down in the comments section. In the next video, I'll probably go back to my processing work for a while, but I wanted to drop in and create this since I did take the time to make it to throw it in my friend's face. Now you guys get it as well. So I'll see you in the next one.